Welcome back to College Algebra, MAT 150. In this lecture, we will be talking about equations of parallel and perpendicular lines. So a line is parallel to another line if you can look at the slopes of the two equations and you can see that they're the same. All right? And graphically speaking, when we talk about parallel, this means that if you have two lines graphed next to each other, you'll see that, well, as close as you can, I guess, depending on the lines, but they will never intersect. And if their slopes are the same, that would make sense. So in this example, let's see if we have these two equations, y equals 5x plus 2 and y equals 5x minus 7. Are they parallel? Well, yes. So from this one, so this first slope, or the slope of this first one is 5, and the slope of the second one is also 5. Since the two slopes are equal, then yes, they are parallel. Yes. The graph of the lines are parallel. To each other. All right. And we also have another competing concept. So parallel and perpendicular. So a line is perpendicular to another line if you can look at the equations of the graph or of the lines, and you can determine that their slopes. If one slope is equivalent to the negative reciprocal of the other, then they are in fact perpendicular to each other. Graphically speaking, what this means is that if you graph them, then they will intersect. So with parallel lines, they never intersect. With this one, they intersect, and in particular, this means that and in particular for perpendicular lines, they intersect with a 90-degree angle. So this means that you would have something, in fact, these are two perpendicular lines, but if you're kind of looking at it out here, then maybe the two lines would be something like this. And that where they intersect, there's a 90-degree angle between them. Further, for the parallel lines, it would look something like this. Two lines that look like they go on maybe next to each other forever and ever, but they never intersect. All right. And further, the last thing I want to mention about parallel and perpendicular is that two lines, if you have two lines, they don't have to be parallel and perpendicular. They can be neither. So if they don't intersect each other, they intersect, but not perfectly. Well, perfectly in the sense of being 90 degrees from each other, then they're neither parallel nor perpendicular. In this example, let's look at these two equations of lines. So we got y equals 5x plus 1 and y equals negative 1/5 x plus 1. Are they parallel, perpendicular, or neither? Well, if we look at this slope, it's 5, and this slope is negative 1/5. Well, they're not the same, so they're not parallel, clearly. The only other thing we have to check, and if it fails this check, then we would say they are neither parallel nor perpendicular, is we have to see if one is the negative reciprocal of the other. Well, a slope that's parallel, or rather that's perpendicular, to the first one is one that would be negative 1, and then of m1, well, m1 is 5, so negative 1/5, and that actually happens to, so a line of a perpendicular slope, or the slope of a perpendicular line, is negative 1/5 to 5, which is exactly what m2 is. So the lines are perpendicular to each other. All right. And this is not typically the type of question we would ask, or the type of question that comes up. It's something more along the lines of one of these. You're wanting to find the equation of a line that maybe contains a certain point. That contains a certain point and is perpendicular to y equals 2x minus 4. for example. So for this one, we want to dissect this, and these questions trip people up quite a bit. So first off, it says find the equation of a line. I'm going to highlight this because when we say find the equation of a line, there's one thing that should come to your mind, and that's what we did at the start of this section, which is use the point-slope form of an equation of a line. So y minus b equals m times x minus a. Where you have ab as a point and m as a slope. Well, so we're trying to find an equation of a line that contains the point negative 1, 2. So we're trying to find an equation of a line that has the point negative 1, 2. Oh, well, that's our point for this an equation of a line. Because that's what we're trying to find, so we're trying to fill this out. We have this part, so we're good there. We need to find then the slope. But it says it contains the point negative 1, 2, and this line will then be perpendicular to this line. So how do we get the slope that we need? Well, the slope that we need is going to be perpendicular to this, or it's going to be, this line is going to be perpendicular to this line. So how do we determine that through slopes? Well, that means that something that's perpendicular to this is going to have to satisfy this equation. Well, in this case we have 2, so we plug it in. 2 is the slope. So the slope of our perpendicular line will be negative 1/2, which means that should be the slope of this thing. So now we have the slope, we have a point, we take those two things and we plug it in, and that's it. So y minus b, b is 2, equals the slope, which is negative 1/2, x minus a is negative 1, so I put an extra set of parentheses within parentheses. So, oops, not equals. So we can just simplify one small step. I usually recommend this. Get rid of the double negatives. Minus a negative looks weird. But then this is an equation of a line. We're good to go. We're done. Another example. Again, so that one was dealing with perpendicular. We may have to find the equation of a line. So we're trying to find an equation of a line that contains this point. So this will be, so we're trying to find the equation of a line. So y minus b equals m times x minus a. And we have ab, which is negative 1, negative 3. But now, instead of given, the line before was given in slope-intercept, where we readily had access to the slope. Here, and it said perpendicular. Here it's parallel, and we're not given a nice form of an equation of a line. We're given 3x plus 4y equals 12. So let's solve for y. So we subtract, so if we have 3x plus 4y equals 12, we subtract 3x. Again, we're trying to solve for y to get it in slope-intercept form, which makes it then easy to find the slope. So subtract 3x from both sides. Then divide both sides by 4. And that gives us y equals negative 3/4 x plus 3. What is the slope here? Negative 3/4. And here we're trying to find an equation of a line, so this equation must be parallel to this. Well, if it's parallel, remember that means it's, oops, that should be a 4, I'm sorry. If it's parallel, that means that it should be exactly the same. Excuse me? So if it's a parallel slope, the slope of a parallel line should be exactly the same as the other line that it's parallel to. So we now have a slope We have a point, and we can just plug these things in. So y minus, again, the b coordinate is negative, so let's put a parentheses there, equals m, which is negative 3/4, x minus a, which is negative 1, so we put in a parentheses there. And then we have a double negative here and here, so y plus 3 equals negative 3/4 times x plus 1. And this is an equation of a line, so we're done. Again, unless it tells you to put it into slope-intercept form, you don't have to. If you want to find the equation of a line, a different method, that is also okay, but you do not have to. Again, this is simple. All right, that concludes everything from section 1.4.